The Certbot cron job failed silently for 6 weeks. Nobody noticed. The 90-day certificate was still valid. Then it wasn't. Every browser threw cert date invalid at 2:47 a.m., and one of these servers stayed online. Caddy runs ACME certificate management in process. The same binary that serves requests also talks to Let's Encrypt. nginx delegates to Certbot, a separate command line tool that runs on a schedule and writes files to disk. Certbot renews when 30 days remain. If the cron job breaks on day 60, you have 30 days before anyone notices. No alerts, no failed health checks, just a countdown. Even if Certbot succeeds and writes the new certificate to disk, nginx won't read it. nginx loads the certificate and key into memory when it starts or reloads. After that, it doesn't reread the files on disk for every connection. If the post hook fails, clients see the expired cert. The renewal succeeded. The file is on disk, but the browser still throws an error because nginx never reloaded. RFC 8555 defines 3 challenge types to prove you control a domain. HTTP-01 and TLS-ALPN-01 are the 2 that matter for web servers. DNS-01 exists for wildcard certificates, but requires API access to your DNS provider. Let's Encrypt gives you a token. You serve it at a well-known path on port 80. The content is the token, plus a thumbprint of your account key. The CA fetches it over HTTP and validates the response. If it matches, you control the domain. The challenge can only be done on port 80. No other port is allowed by the spec. TLS-ALPN-01 works differently. The CA connects on port 443 and negotiates a special ALPN protocol, ACME TLS-1. You present a self-signed certificate with the challenge response in a critical extension. This works when port 80 is blocked. Security-hardened environments that only permit HTTPS traffic can use TLS-ALPN-01 to avoid opening port 80 for validation. Caddy's ACME client is ACMEs, built into the server. At startup, it discovers domain names from roots, obtains certificates from Let's Encrypt or 0SSL, and starts a background loop checking expiration every few hours. 30 days before expiration, it starts attempting renewal. By default, Caddy enables 2 ACME-compatible CAs, Let's Encrypt and 0SSL. If one fails, it tries the other. If both fail, it backs off and retries later. You give Caddy a domain name and a backend. It obtains the certificate, sets up HTTP to HTTPS redirects, and manages the entire lifecycle. No Certbot install, no cron jobs, no reload hooks. If you enable multiple challenges, Caddy picks one at random. Over time, it tracks which type succeeds and which times out. It learns your environment and begins to prefer the challenge that actually works. TLS-ALPN-01 succeeds, but HTTP-01 times out. Caddy will prefer TLS-ALPN-01 without you touching the config. This is adaptive challenge selection. It builds a runtime profile of your environment and adjusts automatically. Caddy pioneered on-demand issuance. A TLS handshake arrives for a domain you haven't configured. Caddy asks a validation endpoint if it should obtain a cert. If approved, it requests one during the handshake and caches it for future connections. Certbot is a standalone Python CLI. When you install it, it drops a system timer or a cron job that runs twice daily at midnight and noon. Each run checks if any certificate expires within 30 days and renews if needed. If a certificate is due, Certbot attempts renewal and writes the new cert to disk. The post hook reloads nginx, so it reads the updated files. If the hook doesn't run, nginx keeps serving the old cert from memory. You can inspect the timer with systemctl. It triggers at midnight and noon with up to 12 hours of randomized delay. The persistent flag means if the system was down during a scheduled run, it executes on next boot. Certbot succeeds. It writes the new certificate to disk. The post hook tries to reload nginx but hits a syntax error in the config. nginx never reloads. It keeps serving the old certificate from memory until a manual reload. Clients see the expired cert even though the new one is on disk. The browser throws a certificate error. The server operator sees a successful Certbot log entry. The disconnect between disk and in-memory state creates a silent failure mode that's invisible until clients complain. Cron daemon stop. Certbot can't write to the well-known path due to permissions. Port 80 blocked by firewall. nginx config has an HTTPS redirect that catches the ACME path before the challenge handler. Post-hook syntax error prevents reload. Every one of these fails silently until the certificate expires. Then, at 2:47 a.m., every client starts throwing certificate errors. You trace back through cron logs, system journal, Certbot logs in varlog let's encrypt, nginx error logs, and well-known path permissions to find which piece broke. Caddy can't obtain certificates if both port 80 and port 443 are blocked. If both let's encrypt and 0SSL are unreachable, it backs off and retries later. On-demand TLS validation endpoint rejecting domains stops issuance. Storage backend unavailable blocks certificate writes. Challenge learned the wrong environment preference. Caddy prefers HTTP-01, but port 80 is now firewalled. Security teams want to close port 80 entirely and only permit HTTPS traffic, but HTTP-01 is hard-coded to port 80 by the ACME spec. You can't validate on a different port, port 80, or it fails. This creates a security versus automation conflict. One operator had Cloudflare in front of Caddy and configured the firewall to allow HTTPS only. Caddy tried HTTP-01. Let's Encrypt couldn't reach port 80. Cloudflare returned 522 connection timed out. The certificate never issued. TLS-ALPN-01 solves this. It validates on port 443 using a special ALPN extension during the TLS handshake, designed for CDNs and load balancers that terminate TLS but don't control backend HTTP routing. Port 443 only. No HTTP required. Both Caddy and Certbot support it. When Caddy's adaptive learning sees HTTP-01 timeout, but TLS-ALPN-01 succeed, it shifts preference. The next renewal attempt skips HTTP-01 entirely and goes straight to TLS-ALPN-01. Certbot requires you to specify the challenge type manually. nginx's verbosity has a trade-off. Every behavior is visible in the config. You know exactly what headers are set, what ports are open, how SSL is configured. There's no magic to debug when something goes wrong, but you write and maintain all of it. When Certbot fails, you check cron logs for whether it ran. System journal for the service output. Certbot's own logs in varlog let's encrypt. nginx error logs for reload failures. And a manual curl to test if the well-known path is reachable. Caddy logs ACME operations in the same stream as HTTP requests. You see challenge attempts, CA selection, renewal successes, and failures in one place. No separate cron logs. No external tool state. The server tells you what it tried and why it failed. One log stream for the entire flow. When ACME certificate authorities have had outages, in some cases, Caddy was the only major client that didn't experience any downtime. Caddy can weather OCSP outages lasting days, or CA outages lasting weeks, without taking your sites offline. It caches certificates and OCSP responses and continues serving. 90-day certificate lifetime, 30-day renewal window for both, 2 attempts per day for Certbot via system timer, continuous background loop for Caddy checking every few hours, 2 default CAs in Caddy with automatic fallback. One post-hook failure breaks the entire nginx renewal flow. nginx serves certificates from memory. Until you reload, the new cert on disk doesn't matter. Caddy learns which challenge type works in your environment and adapts. TLS-ALPN-01 lets you validate on port 443 when port 80 is blocked. In 2019, Let's Encrypt researchers published a paper analyzing real-world TLS deployments. Quote, servers running Caddy exhibit nearly ubiquitous HTTPS deployment and use modern TLS configurations. We hope to see other popular server software follow Caddy's lead. End quote. One expired at 2:47 a.m. The other learned TLS-ALPN-01 worked better and never looked back. Subscribe for more mechanisms that matter.